Hi guys, this is an intro to a bunch of stuff that I just finished doing a couple of hours ago, and it's the setup of the new repeater, the second version of the board for the repeater controller that I'm using the SP32AS or A1S on. The old board is still in here in the repeater test bed here. The new one works. This is sort of the end. This is sort of the preview of the end. But thought it needed a little bit of context. So I have never done um, reflow soldering on with SMD parts on a board, and I have a stencil, and I had the board. The boards came in. The second version board, which does have one problem on it, which the video will show you. But bottom line is, this is the board that I designed to. And the other board, of course, is the same is the first version I designed, which has a bunch of blue wires on it. When I You'll see that also in the video. So there's a few blue wires. This corrects all the blue wires, but introduces a new problem. But it's not really a big problem. In any event, I thought I'd do an intro before I did the rest of this video. It's about 2 hours long, so get your popcorn and get your drink settled in and get ready to be bored. Alright guys, I have no idea how this is going to work, if it's going to work, if anything. I am going to be screwing around with these boards that I just got, the new repeater controller board, and getting it ready to populate and solder. And I thought I would show while I'm doing that. So here we go. So here's our boards. Probably could do a little zooming in that so you can see the thing, and we'll see how that goes. So we'll open up the iris a bit then, fine and dandy. Alright, this is professionally done, as you can see. So there's my new board. Oops, let's do it this way. There's my new board. It's ready to go in theory, whatever. So now we're going to, and I got the stencil for it. So that's the new part. So again, we'll zoom back out again, get it back in focus. This is really professionally done, as you can tell. Alright, so there's our stencil. Haven't done this yet. First open. Haven't got any fingerprints on it. Oh, now I do. Alright. So let's see what we can figure out. So I have half an idea of what I'm going to do. The basic idea is that I'm going to tape this thing down. And there's a nice spot like that. I just need to clean the lens, I guess, right? Is that what that means? So what I'm going to do is I am going to first put all kinds of flux on this. So why do I want to bother doing that? Well, my thought was that if I put this on, it will also act as a little bit of adhesive for all the parts. So that's what I'm going to do first, and I'm just going to scrape that crap off again, but leave a little thin film of it on there. So that's what I'm trying to do first. So we're gonna scrape that off into sort of making the board sticky. That's really what I'm trying to do here. I'm using the professional official squeegee as well. A piece of Langell aluminum. Works pretty good. It feels pretty sticky, just dragging this across like that. So doing its job. It won't evaporate. That's not what this stuff does. This stuff will evaporate on higher temperatures, but not just in the air. In fact, it'll probably get tackier. All right, so here's my idea. Don't know if it'll work, as I mentioned, but it's my idea. I'm sticking to it. See if we can get the reflections going away here a little bit. Turn down the... So basically all I did was turn off the overhead light here. And, okay. So, we're going to get some handy dandy tape. We're just going to stick this thing down. So the idea is for it not to move between anything. Try and not put the SMD parts in the way of the tape. And proceed on that basis. I hope this works. This will be my first. I got 4 more boards. 4 more boards in case of fail. All right. Let's see here. So, of course, using this tape is probably less than ideal, but not sure what else I have available at this time. And of course, you always lose the end. Alright, that didn't work out so well. I think that will be just enough, just okay enough. Did I miss the corner? Maybe I did, maybe I didn't. But basically, again, my idea is to hold the board down in the corners without getting in the way of the SMD parts, so that it's not, the idea is I don't want it to move, because this guy, which this must be the top because it matches up, and of course I got stuff sticking to it already, very good. So let's see what we can do with this. So we need to find all the holes. I'm actually going to look at the screen, the video capture screen, and that looks like it might be lined up. See a couple of little issues here. Oops, lots of issues now. Alright, what's under that hole? Oh, that's a piece of crap that got in there already. Alright. So here again, I'm going to tack down the ends. And I don't know how long it takes solder paste to set up, or to be detrimental to not having it done. So you see, I'm just trying to line up the holes and then get it stuck down when the holes are properly lined up and not improperly lined up. Alright, that's one side. Let's see if we can pull that off on the other side. Alright. And again, I'm looking over at the video result to understand whether I got it lined up or not. As I'm looking at it at sort of an angle from here, looks like it's properly lined up. Alright, so in theory, that's ready for solder paste. That would be the theory. Probably if I was doing this right, I'd actually have the other boards or some scrap boards making it so that this isn't bending. I'm noticing that it's sort of bending around the board. Hopefully that won't really bother me when I get around to this. There's more fingerprints. So that's step one. I'm going to try to continue and figure out step 2 here. So I'm going to stop for now, and we'll see what we can come up with next. So here we are again, different day, different shirt. But we're in the same spot. did some research to find out how long I have to put the solder paste on and put the components on. And it says it's 10 hours. So there's my thing. But here's this ought to be interesting. So here's some information about the paste. I got no idea. Yada yada, pick and place. Yada yada, reflow, yada yada, rework. Okay, so I believe this stuff is supposed to be 138 degrees melting point. So SN42 SN42 AG SN42 BI57 AG1. Well, that ain't what it says here. 42. Anyway, it looks like the 138 is the thing. 270 seconds. 180 to get it up to temperature, which is 3 minutes, so that sounds about right. So we're going to see what we can do. Now, this is meant to be squirted on in some manner. I'm to individually do it. I'm going to be doing the squeegee thing. So what does this say? This piece is only for manual disposing. Do not use an equipment. I have no idea what that is. But I guess we'll figure it out as we go along. Let's see if I can figure this thing out. Alright, so there doesn't seem to be a hole in there. So I'm assuming that I gotta make a hole in there, and I may not even want to do it this way. So let's see here. Lighting isn't working out too well, but let's figure out if I just, okay, so maybe I just want to put it on like that. So I'm going to do that. There we go. Figure out how much I need. You got no idea how much that is. That looks like too much, so I'm going to hope it is. All right. Looks like it should work like this. So we're going to see if this is enough to do the work. Looks like I might have ran out. That looks like it's working. Actually, other stuff, of course, coming in, getting in the way. Go the other way too. Don't have enough. All right. That looks like it's all on there. I don't know if you can see. I guess you can see. That's not so bad. All right, so that's that. It says you're supposed to save it because it's expensive, and yes, it is expensive, but I guess I ain't gonna be able to save it because I can't stick it back in the tube. I need to buy a jar instead of the syringe. That was a mistake. So I'm going to get rid of the excess, though. It looks okay. All right. I'm going to say that that worked. Put all this crap back into here. Hopefully you saw what I did and I didn't have it out of the camera accidentally, which is certainly possible. Put this stuff back in. Let's see what it comes up with. There's no hole in the cap. I just pulled the cap off, putting this back together, stick it back in the plastic, and we'll just see how that works. Okay, so that must not have gone in that. It must have gone in here. All right. All right. All right, so that's that. So in theory now, I have 10 hours to put the parts on there. I'll do a little cleanup with this thing afterwards. And we'll put that aside. Put that on a paper towel there. All right, so here we are in theory, ready to go. So now I got to get all my parts. And as with manually soldering them, oh, I see some excess on some of these things, and I don't know whether it'll be a problem. I don't know whether I should clean it up with solder, with soldering iron after the fact, or clean it up now. I'm going to start with cleaning it up now. Looks like there might be too much on some of these pads. That's too bad. So I think that some of that was caused by the fact that the thing wanted to flex. I think that the way to prevent that, let's see, everything else looks good. Nothing else had the fine pitch. So this would not have worked with a really fine, this is not a fine pitch, neither is that. So I'm thinking that it would have been okay, or that this would not have been okay with a really fine pitch. But what you're supposed to do, and if you remember on the last time I mentioned that, you know, this was bending up because of the way I taped it down. So what you're supposed to do is have a frame that you put, that you make for around it, and then that way it remains flat on it. So anyway, didn't do that. So now I'm going to get started placing all the parts. I'm going to leave this on there so the board don't move around. I'm going to start getting my parts. It'll take me a while. I might do some editing between here and there, but I'm just going to another part of the room to grab my parts. And yeah, I can put that there without too much, well, you won't be able to see what I'm doing, but you can't see it anyway. So I'm going to start with the small parts. I got to bring up my schematic and parts list. So I'm going to do that. I don't have a desktop capture going on this recording. Probably would have been a good idea to do that. All right, so bring up the schematic. Do all the little parts first. That's kind of the recommended way, no matter what, even if you manually do it, is to do the smallest parts first. So there's CAD, KiCad, and this is the wrong board. Open the project. We're going to open the right one. Pull up the schematic. Let me see if I can do another quick video capture. All right, where are we? This doesn't seem to have worked. Schematic. All right, there's the schematic. So let's see if I can do a desktop capture really quickly. Display capture. Display capture. I know it's going to look a little funky for a minute. I can probably edit all this out. Wrong screen. So go to the right screen. There we go. And we're going to size this down properly so that it fits in the corner or off to one side. Probably can't see much of it anyway, so it probably don't matter that you can't really tell what the hell's going on. All right, so I'm going to use the schematic, which, like I said, you probably can't see, and I'm going to start figuring out parts. Put this in the way. You can't see what I'm doing over here anyway, except under the camera, so maybe it doesn't matter that this is in the way. So we need a bunch of I know we need a bunch of 1 microfarad unpolarized capacitors, which are these guys right here. There we go. Upside down. There we go. And we will start placing them and see what happens. Get the old frickin' glasses on. These are the unpolarized ones. Yes, 1 microfarad. There we go. So that's going to be C3 is one of them. And so I'm going to be the pick and place machine here. C3, good question. Where is it? Who the hell knows? There it is. So let's see how this, being able to kind of stick it in place, works. I can tell you right now, it don't work worth a damn. It don't stick. Nothing there. As soon as I take this tape off, everything's going to pop off the board. Oh well, so that's what's going to happen. I know that C4 and C1 and C2 are all the same thing. So I'm going to keep doing that. I would really wish it would stick to something here, but it's just not. This is just gravity. All right. 1, 2, 3, 4. Okay. All right. So 1, 2, 3, 4. 4. All right. And then I've got 7, 8, 9, and 10. They're all a bunch of 0.1s. 0.1s, 7, 8, 9, 10. So there's 8. There's 9. Well, that was 9 and 8, so I can do that. All right. It's interesting. I got some overrun here. Like something got swiped on it. Did I rub it accidentally with something? I don't know. There's C7. And there's a lost capacitor. It's here somewhere. Oh well, I might find it later. Alright, so continuing on here. C7. Now I gotta find C10. There is C10. C10. Alright. That's 10. That's 7, 8, 9, 10. And I believe that's all of the unpolarized ones. Yes, I'm just looking over at my schematic. So I'll put this thing away. All right, so there are some. Well, what I'm going to do is I'm going to turn the recording off, and I'll just keep populating my board and then seeing what happens in the final result. So here we are again, kind of in the middle of the build. I got a bunch of got all the resistors and some of the capacitors loaded up. I'm doing the transistors next because they're the next biggest component, so to speak. That's again doing the smallest ones first. Transistors on this board are all the same, so we just have to find them. Q1, Q2, Q3, and that's it. Alright, so let's do that. Q1, so that's a transistor, right? Alright, Q1, it's right there. Get that in place. Hopefully you're catching my audio, I don't know. The VU, yeah, there's a bit of a VU meter going over there. There might be some echo, I got no idea. This is highly professional. Let's do the next one. Alright. Q2. Q2. Hopefully I won't sneeze. That's going to be the last thing I need to do right now. There we go. Q3. Alright, and where is Q2? There's Q2. So I'll get that just to show you what goes on here. They always ship you the tape and reel type thing as if you're going to feed it into a machine, even when you're buying hobby quantities. But just a matter of fishing them out. So try and get that in place. I'm still a little bit worried that it's, damn you. Still a little bit worried that when I pull this board off, all the parts are going to go flying. Trying to tap it in there to get it in, but it's not always working. Alright, so get this back in the little baggie so I don't lose track of what it is, because as you can see, there's a marking. Well, maybe you can't see, but there's a marking on the transistor, but it doesn't have any bearing on what the part number is. Alright, so we got a little 0.1 microfarad capacitor to put on somewhere, if I can find it. 0.1. Only got one of those. There we go. You have to open a bag because I don't know what the other bag has in it. Alright, so take one single 0.1 out of this tape and reel. No, I just banged into the board and knocked some stuff out. Of course I did. Alright, so there's my capacitor. Fix the board. Alright, so there's my item back on the board. Back in the day, they used to make actual adhesive that you stuck on the board first, and then you put your parts on it. Alright. 0.1. Come here, you little thing, little stinking capacitor. 0.1. The only one that's on the board, bypassing the little op amp there. Alright, so that is that board, that thing. Now we got the bigger capacitors to do. So we've got a small version of a 0.1, or a small version of a 1 electrolytic that's around here somewhere. Right. Can't put that on the board, can't put that on the board, and we have here another 0.1. That's probably the one I was looking for. We have here another 0.1 because you can't run out of 0.1s. You can never have enough 0.1s. That's not it. That's not it. not it. That's not it. Gotta be here somewhere. So we'll start over. All right, so we're looking for some big capacitors. So here's some big capacitors. Are they the one? These are the 10s. We need a few 10s. I know that. So we'll get them out of there. 10s. So it says, whichever way it says it. So there's a nice 10, and I need two more. Yes, I need 2 more. All right, didn't I just put down a 10? It's gone now. Wonder where it went. All right, 10, 10. Oh, it never came out of the tape and reel. All right, so throw this back where it belongs. All right. So there are my 10s. I actually shouldn't do these yet because I have a bunch of 1s that I need to do. So let me find the 1s. The polarized ones. The electrolytic. I have a bunch of electrolytic 1 microfarads that I have to find. Okay. Point one. That ain't it. 0.1. All right. No, 1K. Pins. Resistors. 4K, 4.7K, 10K. Some connectors. 10K. Alright, it appears that the 1 microfarad electrolytics got misplaced somewhere. Alright, so we're going to shut off the recording, look for that stuff, and pick it up a little bit later. Alright, here we go again. So I've got most of the rest of the parts collected. Oh, I got another set of regulators I need to collect, but I've got my electrolytics, my 1 microfarad electrolytics. And I'm putting on there now. Someday I'll get the damn thing on there. All right. Polarity. Positive is on the open side. My tweezers are magnetized, unfortunately. Causes some problems. Positive on the open side. Yeah. I don't want to stick my finger in there, but I probably should. Alright, get this thing turned over. And get it cleaned off so I can tell which side is which again. Alright. Positive side is the open side. These tantalums are ferrous, apparently. I probably create about 32,000 shorts underneath all these things. Positive on the open side. And so I'm saying positive on the open side because the marking on these guys is that way. The open side is the positive side. The way I try and remember it right now is that it's a battery. Looks like a battery. Alright, so then I got these little Zeners that aren't designed for this at all. I think I'm going to save them and hand solder them, because I don't think they'll flow solder properly. The Zeners I had already, and they're not 0805s, so that goes here and here. Alright, so that leaves us with all these little variable resistors. So there's 8 of them. Those are the gain controls, gain and gain and volume, I'd have to say. I basically use kind of a standard circuit. I use a variable resistor in the feedback loop of the op amp, and another variable resistor on the input that's set up as a potentiometer style volume control. So that lets me, if it's too big, the gain control on the positive input lets me cut it down. If it's too small, I got almost infinites until the thing starts oscillating gain capability on the feedback loop. And usually I do a compromise in between. I'll do a little bit of cutting it down and a little bit. I do that as a generic circuit so I don't have to screw around during actually using the board with figuring out what proper resistance values have to be for what, etc. Anyway, continuing on here. So basically every one of these is one of them's a input level and one of them's a gain control. And they're all 10Ks. Little tiny variable resistors. 3 terminals. Alright, so that's the end of that. Now we need the little op amp. We need to figure out which one is pin 1. The interesting thing is that I've noticed these days is that they don't actually mark pin 1 as far as I can tell. Now what they will do sometimes, they'll put their company logo, and you can't exactly, maybe you'll catch as I twist this in the light, you may be able to catch the marking, but it's an ST Microelectronics chip, and so they put an ST logo near pin 1. The other thing that you can generally do is they will make it so that it's readable if pin 1 is to the left and down. They make that so that that's the reading position. Okay, I got these regulators to do. I got to find them. I had them here, but I put it away as I was searching for my 1 microfarads. And they'll be here somewhere. Alright. And there they are. Alright, so we have a whole package full of different voltage regulators. SMD style. So this board takes a 2.5, a 5, and a 3.3. The 2.5 I strictly didn't need. I'm using them for middle bias, so to speak, for the op amp, and it didn't really need to do that. So that's a 5-volt one there. And the 5-volt one is U4. And I'm going to smear the solder paste, of course. So let's try again. And there I did. I bridged it right there. Ain't that something? I have a feeling that that'll just fix itself, but there's no point in tempting fate. Damn you. It wants to stick to the... Again, the stupid magnetized tweezers is killing me here. Alright. So then I need a 2.5. And again, I'm referring to the schematic to figure out where it goes. 2.5 is 2.5 is 2.5 is, oh yeah, the op amp is running at 5 volts, just FYI, rather than 3.3. It's a TL084. It can kind of run down there, but doesn't really like to. Alright, 2.5 is U5. That one. Alright. And I need a 3.3 volter, which is what everything else runs at, is 3.3. That's kind of the new standard for SMT type stuff. The other voltages usually go down to 1.8. There are lots of other options in the middle. This bag kind of tells you what the options generally are, but you know, 1.2, 1.5, 1.8, 3.3, 5.0, etc. All right. That's all the parts except for this guy. And so this guy has to go on there, and I'm going to try not to smear anything as I put it on there. That's not working. Let's see what we can do here. All right. See how that did. It looks about right. No idea if that's going to solder right. Give it a little push down. All right. So that is ready to put on the hot plate. And I'll bring that in, do a little cleanup, and I'll bring that in a minute. We'll just do a commercial break. So here's my little doodad. It's a hot plate, temperature control hot plate. And I'm going to prep a couple of things here. Number one, I'm going to be I've got some tin plates over here. Some plates of tin, which I'm eventually going to be used for shielding type boxes. But I thought that it would be good for handling the PC board and put the PC board on that instead of directly on the hot plate. And that'll give me a capability of lifting it off of there and putting it on something cooler, which I'm going to prep something cooler as being a couple of layers of toweling. Make some more room here. I tend to clutter up my workspace. Always, always. I then find 52 tweezers, 500 screwdrivers, and other things along the way as I do that. So I'm going to get this ready here to the side of this. Find my squirt bottle of water, which is right down here. So what that'll let me do is it'll let me cool it down a little faster than this thermal mass would allow, and get it off of there. I also have a nice handy dandy set of gloves that I got as a separate thing, that they're silicone and material kind of gloves. Don't know how I'm going to do this yet. So temperature controlled, so I can set this up. I'm going to go I'm going to look at this temperature curve thing again, if I can find it. There it is, hiding. So it says 165 C maximum, 138. So and at the 240-second mark, and then drop it off. So that's kind of what I'm going to try to do. This is a manual setup. The thermal mass is too big for it to come down very fast, but this should make it work okay. So for right now, we're moving this over here. We'll see if we can get our project off the table. Without everything popping off. That's half the battle. I moved the main chip, unfortunately. To move that back, we might as well get it fully knocked out of place, which it did. Look at that. Wonderful. All right, let's see if we can drop it back in place. And we got it off without everything popping off. Now we just got to make sure that that guy is in the right place. It's only off by a whole pin. No big deal, right? I'm going to inspect the solder paste because it probably smeared all over the place. So we're going to do a little of that. And probably would have been okay. There are a few potential bridges that got smeared across. I really think that they would disappear with the surface tension of the melted solder, and the fact that there's extra flux on the board too. But no sense worrying about it, fretting over it. Just do it. It has a 50-50 chance of working. It'll either work or it won't. 50-50. All right, let's see what we can do here. And of course I'm smearing it some more. There may be some spots here that are going to need touch up anyway. Let's see if I can get this son of a bitch on there without smearing it all over the place yet again. All right. So we have it sort of in place. It's going to smear a bunch more, unfortunately. Let's just hope this works. This is probably the worst part of it. Bridges are tougher to find on these. I may end up reflowing it again, just in case. All right, so here's my idea for putting the thing on here. So I have something to easily lift it with, and it should transfer the heat well. This guy then should go up here. And I already see, yeah, very good. That worked out well. Perfect. No problem. Let's try again. Oh, damn it. All right. Yeah, this is really fun. All right. So I got to fix a bunch of parts. I'll fix them on here. All right. So let's see how bad we did. How bad off we are. So this guy has to go back over here. All right. This guy goes back over here. This guy is a nice little diode. This guy's a nice little variable resistor. Doesn't look like the paste got too screwed up. This capacitor is 5 miles away from where it should be. And looks like everything else is pretty much in place still. Pretty lucky. Alright, so now I gotta fix this crap that I screwed up again. I'll be lucky if I don't have 24 bridges under every one of these that I won't be able to see or repair without taking the whole thing off. And I'm going to make sure that there's no extra bridges over here getting created as well. Oh, you weren't able to see that. All right. So here we go again. I'll get this unbridged. With the solder paste. All right. Now let's see if I can stick this thing back on there without smearing it up 10 times worse. Yeah, who knows? Who knows what damage I just did? I suppose I could leave this off and hand solder it. You know, at this point, that's probably the best thing to do. Well, I'm going to put my trusty ohm meter on all those pins, only a few of which should actually be shorted. All right, we're putting that on the hot plate. And we're going to move the hot plate to where we can record this thing, possibly, while it's heating up. And I guess that's good enough. I think we need to turn down the illumination. Has still other kinds of illumination coming after it. Maybe a little bit. I don't know. All right, all the parts still seem to be there. Focus. Well, let's hope that this is going to work. All right. So the best I can do is do it. So I'm going to get my gloves on so I can get ready to move the stuff. And look at my little profile again, my little temperature profile again. And turn the thing on. So we're going to set it to 100 to begin with. And get us up in the neighborhood. and then we'll push it up from there. So this thing takes a while to heat up. I'm looking at the screen to look at the board because I can get a better view of the board there, or if not a better view, another view. If there's something that is not in the right position, so you guys are probably yelling at the screen right now, don't do it, that's in the wrong place. Well, if it is, it is, and we get to fix it up later. So we'll let this rise up. They say 3 minutes. I don't have a timer going at all. Not sure it really is that critical. It's 3:23. They say go up to 130 degrees after 180 seconds. They say 90 after 90 seconds. This is probably going to be pretty close to the curve they want. You may or may not be able to see the tacky flux that I put on the board getting a little shinier. It's definitely melting in some sense, or yeah. So we're at 100, so we're going to continue on. The melting point is supposed to be 138, so they want me to take it up to 130, so we'll go ahead and do that. Oh, to 180 seconds, so I'm even going faster than they really want. Solder is not yet melting. Solder paste is kind of glomming together. I don't hold out much hope for that big chip. Let's hope it just works. All right, so we're at 130. It's not even close. So we're going to jump it up to the 138. I'm just going to go up to 140. Let it melt. They want you to take it up to 165 in the next 30 seconds. So we'll might as well do that. Let's see if it melts. There's some steam, you know, some fumes coming off of it right now. Still don't see anything melting. Oh, we got a capacitor. We got this guy in the wrong position. See if we can nudge it over in the right place. All right, I still don't see any melting. I do see more glomming together of the solder paste over on the big chip. 165, it's supposed to be melting by now. It has not melted. Of course, that is the table temperature, not the, oh, there, I see it starting to melt the solder over here. Melting the solder over there. Melting the solder. Seems to be all melted. It does seem to be all melted, but not all of the parts also melted that. So we're going to take this down. It is smelling kind of funny. Not all of the parts soldered with the solder. Like that capacitor has got no joint there on the one side. It has maybe on the other side. All right, so I'm going to get it to my prepared cooling area. Trying not to drop it. And we'll just turn this guy off. Looks like I didn't drop the temperature at all, did I? All right, so in theory that all soldered. So we're going to be finding that out. I'll move this aside. Move the cooling setup over here. and it may have worked. I don't know. So it does appear, yeah, it does appear that the mess that it was making with the solder paste over here actually soldered in the end. Can't see the other side. I won't see the other side until it's done. Let's see what the temperature of the board is. 94°C. So we'll let that come down before I touch it with my fingers. I think that'd be a good idea. When the solder melted, it did pull away. It absolutely did. The surface tension did its job. I don't know that there's enough solder paste. There was enough solder paste in some places. I don't even know if this thing's soldered. Yeah, it did solder some. It's stuck somehow. The parts aren't moving. This one I'm suspect. No, that one worked too. I don't know. I'll have to touch it up with the soldering iron, but it mostly worked. As far as I can tell, it mostly worked. I'm going to inspect them. I'm going to do some continuity checks on it. Temperature of the board is 60. So what I'm also going to do next is I've got another little gadget that I bought that I'll probably bring in here and use to clean up the board a little bit. I'm just looking closely here. We'll switch glasses to the micro glasses. You know, it actually looks like it's soldered every damn pin and it did not bridge them, which I find kind of amazing. I half expected it, but it's still kind of amazing. So, where are we now in the temperature? 48. I wonder if this tin is holding more heat than I would expect. It may be. What's the temperature of the tin? I know this will be an invalid reading because it's reflective. Let's find out. Okay, it's room temperature, or nearly so. The board, 40, so it's a little warm. Shouldn't need these anymore. All right, and the board is just a little warm. Okay, so we're going to go to the next step here. Pausing yet again. All right, so here we have yet another tool in the arsenal. It's an ultrasonic cleaner. I have distilled water in there. I'm going to rearrange some things so that you can see that, and we're going to watch it clean that board. Now, one thing to note is that I don't know whether or not the solder flux that's in the solder paste will actually work in the same way that it works, that I know that the other flux that I use works. All right, so there's my water, there's my cleaner, there's my board, which of course doesn't fit. It is distilled water, and then what I do is I just either heat it up with the SMD rework, or I'll put it on the hot plate again to get rid of the water. Of Cross your fingers. And I'm not sure you'll be able to see the action. If you can see some white areas, that's the solder flux. You may or may not be able to see any white areas. Yeah, there's not enough resolution really in here to see that going on. But it is cleaning off some of the residue. And we can help it along a little bit as well. And it's no longer distilled water. That's for sure. But the only thing in it is flux. So, and this is supposed to be a no clean flux. I mean, it's certainly not acid core. We'll let that go for a while. Interesting thing is when this thing is running, I feel a headache, which is kind of when I'm too close to it. So it is still creating some white residue as it cleans that flux off of there. Doesn't seem like I'm pushing any of the parts off, so they're all stuck pretty good apparently. You still can't really tell on the video, but the water is getting cloudy. So that ooey gooey flux, which is this stuff here that I use, is really sticky, and it's really hard to clean off. You clean it off with a paper towel, all the parts pull the paper towel apart, you got nothing. If you just use the brush on it, it just kind of smears it around. It doesn't go anywhere. The ultrasonic cleaner actually gets it off the board at least. I'm going to do a quick visual inspection and feel it out as well to see if it's clean or not. Yeah, it worked. There's some areas here that still have that crap on there. We'll put it back in there and turn it around in case there's some standing waves going on in here. Alright. This board barely fits in that little thing. I might end up getting a bigger one. So it is working. It is cleaning off the board. A lot easier than like I said, brushing off the goo just doesn't work. I wonder if the buzzing is actually overriding my voice. Probably I'm distorting like hell, but not much I can do about that right now. I think it should be pretty close to done. Yeah. None of the white stuff is on there anymore. So we'll pad this dry. We'll pad this dry. We'll get rid of the ultrasonic cleaner. And we will bring back in the hot plate. the hot plate is still actually rather warm, still rather hot. So we're going to go ahead and make sure there's no water underneath, and then just go ahead and put it on there. Plug this thing in, turn it on to get the temperature. Temperature is 52C. No, that's the set point. 50C set point, 90C set point. Can't tell. That's the set point. That's the temperature. That's hard to believe. So the board is now 82, 85. Okay, well that's good. So the set point is 50. The thing is still at 90, believe it or not. That's hard to believe, but let's see if I can. I can't set the E or E value or C value, whatever the hell it is. It says that's 28, which is wrong, but it does say the board is 92. It is coming down. There's a lot of frickin' thermal mass on that chunk of aluminum, or whatever it is. I believe it's aluminum. But that should bake off all my water. And you're not seeing it because I didn't put it in the right place, but that should bake off all my water. That might be left over. It doesn't look like there's any water at all on the board right now, but who knows what's inside the little chip. Drops of water are on the little chip, or in the little chip. Don't really want to send this up to boiling, I don't think. I guess I could, and that would make it evaporate faster. But you see I don't know if you could see the drops, but they did evaporate. So the hot plate is still hot, not boiling off water, but it should help it evaporate pretty quickly as all the parts got up to 85 or so degrees C. So there is a spot of water that just disappeared off of the board from when I tapped it like that. The parts inside of this little module. Yes, this is rather warm. Just trying to drive off the as much water as I can by doing that. So I'm going to let that sit for a while, and I'll start recording again in a few minutes. Alright, so here we are again with that board, and it seems to be all watered out. I did have a chance to do an inspection of some of the pins. So let's get this guy, let's get rid of the hot plate. Hot plate is still sitting at 60 degrees. All right. So here's our board. Somewhere in this neighborhood. And I'm not sure if I can do an inspection with it, but I'm going to try. Here's what I can. Don't know if I'll be able to hold it steady enough. But so you can see there most of the pins, little castellated edges, except for those last two, which, if I remember correctly, most of the solder paste was smeared off of that by the time we got around to doing it. This guy, I mean, it worked. There might be a couple of questionable pins there, but it worked. I will be checking for bridges. Um, Everything else is pretty clean. I don't know about those guys for sure, those regulators. When I see it from my point of view, um, directly, see, I see a nice solder joint on the big tabs. Not sure I see, oh yeah, I guess I do see some solder around the other pins. Those big capacitors worked fine. So if I go over to this is one of the suspect ones over here I wasn't sure about. The C3 is one I was looking at that I wasn't sure if it might be soldered or not. But a little touch up with the soldering iron. So all in all, this was in a sense easier than the individual soldering, because when you place and solder, the part wants to come back out up with the solder. And I mean, with the soldering iron, you put the thing down there, you need 3 hands because you got to apply a little bit of solder. Although I usually try and put that on the tip of the solder, but that doesn't always work. And the tweezers fall off and the thing goes flying, and then you're soldering. So that's this. That's all I'm going to do for now. I might add to this later, but I'm going to check for some continuity. I might as well start doing a little bit of continuity testing right now to see if there's any of the only thing that I think is going to be a problem, as I mentioned, is the bridges underneath, if there are any. And nope. The reason that one beeped is because I know there's a capacitor across those pins. Adjacent pins are, just double checking, adjacent pins are not bridged anywhere. That was me. Adjacent pins are not bridged. Totally surprised at that. Not because solder paste and this type of soldering is not expected, but because of my technique rather than anything else. And again, nothing is bridged. Huh. How about that? And it did solder. Some of them are a little light because I think that was a capacitor again. Yep, absolutely was a capacitor in the circuit. One of those 10 mics over there probably. All right. Now let's see here. I happen to know that ground is here and here. Oh, that's soldered. Doesn't look soldered to me, but that's soldered. That pin is soldered. The top one, I believe, is also ground. How about that? Wow. All right, let's look at this capacitor, this questionable capacitor that I thought I had here. So I'm going to look at this side. I'm going to just touch the top. No, that's not going to help. I'm going to touch the top of this and then the pad. It's soldered too. Amazing. Wow. Actually, this worked. How strange is that? Everything appears to have worked. Let's let's check out these guys. Again, the top of the pin and the pad. Absolutely. Top of the pin and the pad. Absolutely. Son of a gun. Now that one looks like it might have failed. Nope. Top of the pin and the pad. Alright. Top of the pin and the pad. Wow. Of course, I guess this one cheats because that is connected to that. Top of the pin and the pad. Wow. Still feel like I should touch them up because they just don't look good enough. Here's another suspect one as far as I'm concerned. Pin in the pad. Nope. This actually worked. Wow. What's up with that? Oh, here's something interesting. I don't know if you can see it or not. I'll have to redo that. Let's see if we can see that. So there's a capacitor there. C15, no, C14. C14. It got turned sideways, so when I bump the board, so I'm going to have to take that one off and put it on correctly. That's no big deal. Let's see if it actually is connected right anyway. Let's see here. So these are all grounds. So I can take this guy over here and compare it to that guy right there. Yeah, you're not connected. The top of it is harder to test. Anyway, I'll take that one off and fix it. Alright, well the rest is hand soldering. I don't think that you'd find any of that very interesting. And I'll probably add to this when I have the board working, which I'm encouraged that it probably will work. I have some more hand soldering for these connectors up here, and that connector there, and this guy over here, etc., etc. And all the test points need to be hand soldered because they're through hole. So there's some through holes in there, so I got to do all the through holes. All right. So maybe I'll do a little bit of soldering. So I'm doing a few of the big IDC connectors here. And we will just, the ones with ground are always the fun ones to try and get to solder. Just gotta leave the frickin' heat on for 20 minutes or more. Get them going. Do them first. I don't know why. I should probably tack it with something else first. This is me just soldering along the way here. And yes, I touched the solder to the soldering iron, not to the part. I do have the little beveled edge soldering tip, which is quite helpful in getting the heat to the pin and that. The reason I do the solder to the soldering iron is I usually get it on there, and then what happens is the solder helps it actually heat up the part, or the pin in this case. Oops, shouldn't have done that. My pins fell out. Alright. I'll get this back the way it should be. We'll tack it from a different corner first this time. Now I won't do an ultrasonic clean this time. That one looks like it's, oh, yeah. I won't do an ultrasonic clean this time. All these pins are ground, so they're all going to be hard to do. Sorry. We'll just give it a little boost. This little soldering pencil thingy has a little boost mode. You push a button and it zooms it up to wherever you want it, or to a separate set point. It helps you get by these ground pins. These are all ground on this thing. I did this so that a ribbon cable actually has some shielded signals, because this is where the repeater interface would go. This is actually pretty tough to solder right here. So I am doing my soldering iron boost button, but it's not getting anywhere. Oh, that's another thing. Somebody, Phil told me that a friend of his said he started using this and never goes back. Absolutely, never go back. This works the best. You don't run out of tips. It cleans it perfectly in a way that water never did. And this is going a little bit quicker now because that cleaning of the tip that I just did in that stuff, which that's all you do. You just do that. Nothing else to do. And you turn the stuff over every now and again. But once it's clean and shiny, and there's nothing better in terms of getting that tip clean. And what the water can do is it can start corroding the tip in the heat. And this just avoids that. Anyway, last pin. I won't clean it again because if you do a good soldering job like that, there's so little flux on there, and this is no clean flux as well in the core. I'm not even sure you can see it. You can see a little bit of flux there, right? But it's so minor that it ain't even worth trying to clean it off. And that flux won't come off in the ultrasonic cleaner. It's too hard. All right, so we'll do some more assembly here. So the board is assembled. All the parts are on it. Touched up a few things, not much. Everything I checked has proper continuity. I got all the connectors on. I got all the test points on. This one I didn't have, but it's kind of a future expansion thing for injecting voice into it. And it basically just needs a jumper on it, which I've installed the jumper on there. You probably can't see it on the first two pins to basically pass it straight through. You can probably see a few of my touch-ups, but cool thing about that solder paste solder is if you warm it up, it wants to stick, it wants to bridge to its connected part almost by itself. There's nothing you need to do, and it happens quick because it's such a low melting point. What else can I tell you? That's the board. That's the whole thing. So I figured I would let you watch the smoke test. So I'm going to do the smoke test in two stages. The first one is I'm going to apply the programming. This is a little serial port chip, right, with 8 pins on it that could correspond to an old ESP8266. And I designed this board so you can take this kind of a programmer, which is for a different chip, but it uses the same programming style, and just stick it on there like that. There's also this little jumper which says, hey, I'm going to take power from the programming port, or I am not. And with the jumper off, I'm not going to take power from the programming port. So what I'm going to do right now is I'm going to plug this guy in to USB. Okay, and now that board is turned on. You really can't tell. Unless I was sending some serial data, you wouldn't be able to. That's the only time you'd tell. Plugged it in, make sure it's in the right place. And then I'm going to quickly, we should get a green power light right there. And that's the only light that should come on. It doesn't really tell us a lot, but it tells us something. So what I'm going to do initially is I'm just going to be doing this quickly with tweezers to just get to see if we get a green light. No, we don't get a green light. Oh, we do get a green light. Oh, Command COR, and PTT. Now we get those because they're being dragged down by other parts of the circuit that are not energized. But this actually worked. So we got a COR, we got a power, we don't have a PTT, that makes sense, and we have a command COR. All of that kind of makes sense, I believe. So that's half the smoke test done. That actually tested a little bit of the circuitry. So our next smoke test is actually connecting up a power supply. So we are going to connect the power supply. So first of all, we know ground is ground. So that's obvious. It says ground right there. We're going to get the power supply set up for 10 volts, which is what it can take. It can take anywhere from about 7 to 12, 14 volts probably. I'm going to set the power supply here to, so we'll set the power supply. The power supply is set to 9 volts and with a volt limit kickoff of, and if I look underneath here, you can kind of tell, maybe you can't on the, over there, but that first pin there is actually my power input pin. The first one on, I guess, the left side it would be. So that's going to be that guy right there. That's my power. Right now my power supply is off. We'll get our positive signal in, we'll double check our wires, and we will turn it on. And again, it might get dry. This thing hasn't been programmed yet, so it may not do anything. And hopefully it won't smoke anything. So it's only pulling 76 milliamps, which makes sense to me. Nothing is getting hot. We have the, oh yes, we did get a hot, and I just turned it off. We actually popped the 5 volt supply regulator. So there you go. So why did we pop that with only 76 milliamps? Not sure. So we'll have to figure that out. That was interesting. Did we get anything else hot? We got nothing else hot that I can see. So we're going to try this again because it's what's done is done. Power supply is off. Let's see what we can do again. So the power supply is back on, but we're not. Now we're getting a 2 amp limit. Yep, and the 5 volt guy is hot. All right, so now we got to figure out how Mr. 5 volts got shorted. So that was fun. Well, too bad it didn't work on the first try, but that's how this shit goes. All right. Okay, I'll troubleshoot this and come on back. All right, so here we go again. We replaced all the caps and the regulators because every one of my capacitors, tantalum capacitors, was installed backwards, because the symbol for the diode on the board and the symbol for the capacitor on the board for the polarity is opposite. So that's fun. We know the diodes worked, we saw them work. And this should work okay once so I didn't want any stress parts on the board, so I just replaced them all. I'm just going to double check that the right, so that's one's 3.3, that one's 5, that one's 2.5. Yeah, that one I'm just making sure that the 3 different regulators have the right value. So the power supply is off. We're back. I set the current limit to 1 amp, but I'm sure I would pop stuff regardless. So this should work better. And let's continue on. And that issue should not have bothered any chip on the board. So because it's not like it got the wrong voltage or anything. Just would have overstressed the regulators because the tantalum shorted as soon as they got a backwards, or soon after they got a backward voltage on them. And so turn it on. 70 milliamps. And by the way, this thing, this display that I on my power supply has a nice little graph on it. So when I look back, it did go to 2 amps, but not right away. Just checking the hot spots. 67 milliamps. CPU, that CPU is really not doing anything, so that's why it's going to be like that. No more power drain, no more peaking. So that part looks to be working. So we'll turn that off. We will attempt to program it with the real program. So I'm going to plug that in. I'm going to bring up my stuff here. We'll turn on the desktop. We'll bring up the Arduino IDE. I'll turn on my desktop and I'll move that program over to that desktop. And maybe we'll make it a little bit bigger for the moment. I don't know. We'll just make that bigger. That doesn't really help any, does it? We'll put it over the board for now. So I'm going to go get the right program first of all. And it's going to be the E1S repeat B. I guess not, it'll just be that one. It'll be the repeat 1 FM test tree play repeat 1. I guess that's it. Alright, where am I? Alright, so we have to give it the right port. I think it's COM29, but I'm not certain. And let's see, let's verify it's COM29 or not. We'll use a different program to find out. 29 USB serial. So those are the flex radios, serial. Probably COM24 is probably right, actually, not 29. So we will change that, COM24. And we will try and send it a program. Oh, that won't work without powering it up. So I will power it back up. And we will send it a program. Hope, let's give it a different, we also have to give it the right board. ESP20 in dev module. Actually, it's the rover module, I believe, but we'll just use the dev module for now. Rover module. It's actually, I'm going to leave it at that. See what happens. So of course it's compiling that nude. I'm covering up my little, I'm covering up myself here. There you go. So that's compiling, and it should start programming. And it'll, if it programs, at least it should tell me that the main chip is not dead, which it shouldn't be, but one never knows when doing these amateur operations. Still continuing on. I'm watching it compile on a different screen. The one that I'm capturing and sticking in there. All right. Programming, connecting. Okay, it's programming. So it's talking. And you notice the lights went out, except for the power light. That's encouraging. I believe that should be the case even when it fires up. Yeah, I'm not sure why we have a command COR light on. That shouldn't really be on. So we are in good shape, I think, except to install it and see if it really works. So while it was programming, it took a little more power. Now that it's programming and running in a normal situation, it's also running 88 milliamps. Now, how can we tell if this is working? Well, one of the things we can do is turn on this serial monitor, give it a reset, and it is running the right program. And it's not programmed for Wi-Fi or anything else, so that won't connect. This is working. The program is working, at least. The rest of it, who knows? Certainly the levels are not set yet. But I'm confident enough that I would actually stick this in the repeater next to try it and see if it'll actually work. What I'll probably do first is I'll probably get the display. First I'm going to double check some voltages. I'm going to go get the display unit. All right, so here's the display too. You actually couldn't see what I was seeing with regard to the lights. So I got green and yellow, and I don't really expect yellow, but it's not killer. I am going to check the voltages on this on the connector that goes to the display to make sure that nothing got put on backwards. So if I look at this, I can't easily tell. There's a specific, this is what I use for programming that guy. The display, got the same connector on it. If I can decipher how I'm getting 5 volts from this guy, VCC, third VCC is that guy, which goes to the end, which goes to this end, which means that if I plug this in and I look at this end, I should have 5 volts here, I believe. Could be wrong. We'll find out. A -5 because I got the probes backwards. Alright, so 5 volts there. 5 volts on that pin. And there's ground, and there's my 5 volts. So I should not be blowing up my display anytime soon. I'll just double check that again. Looking at this pin out, which I know is correct. And looking at where VCC comes from, it's the third pin from the end. Third pin from the end is the edge wire. If you can see that, third pin from the end, VCC. Third pin from the end is the edge wire. The edge wire goes across to that pin. That pin should be +5. Therefore, that pin should be +5. Therefore, that pin should be +5. And it is. Take my word for it. I don't have the display in the view, but it's there. All right. So now I know I'm not going to blow up the display. I should be able to power up the display though by plugging it in and seeing if give it a reset. It definitely is talking to it. That's a good thing. So I can go plug in my Wi-Fi. We'll do it with this guy. AS. You really can't see it, can you? Oh well. Let's turn off the overhead light completely and see if that helps you any. Not really. I can probably change the iris a little bit and get it to work for you. There we go. AS. 1G is and my network is oops, yeah, that's right. 1, 2, okay, set. And if we give it a few seconds or more, it should eventually come up with a connected status. It might only check once per minute, so we'll not worry about that for the moment. This thing seems to be working. Click ID. Okay, if I make it ID, it did turn on PTT. It did turn on, which is TX. That's good. I'm still wondering about command COR. That shouldn't come. If that's on, so should this be. So there's something going wrong with that. So advanced. Nothing really I should set here. Main. So frequencies 434. The reference 10 megahertz. All right. Well, this is really correct as far as I can tell. Obviously, again, the level will be wrong, but it is functional. So that's not so bad. All right, well, we're going to power this guy down and move on. So right now it's taking 200 milliamps, and the reason it's taking that is it's powering this guy. But in addition, it's got the Wi-Fi activated. Does it in fact have the Wi-Fi activated? Not yet. Well, if I do a reset, it'll cause it to do it within a few seconds. And apparently not. Don't ask me why. I'm not going to worry about it. Oh, and it didn't set. It didn't save. Oh, I know why that is. So it has no file system. I have to load a file system onto it. I'm going to close that. I'm going to go Tools. And we're going to go and give it a little FS data upload. Little FS. That's wrong. That's the wrong one. Where is the right thing? ESP32 sketch data upload. That's going to upload you can't see that again, so let's go back, bring the desktop back up. So here I'm going to do the sketch data upload, which is going to put some data on the chip through the same programming port, what it's doing, which is a file system. There's a little file system on there, like a FAT32, but it's not FAT32. And that will allow it to save the data. Without doing that, it can't save any data. All right. So now, interestingly enough, it did save it somewhere. Don't ask me where. But it did save it, and it actually connected, and we have an IP address. So everything is working, but most of this is actually the CPU happening. So that doesn't necessarily tell me a lot about the repeater functions or any of the rest of the board. Again, we'll check for any heat problems. There are no heat problems going on the board. The 3.3 volt regulator is a little bit warm, but that always gets warm because it's dropping from 9 volts to 3.3 and it's a linear regulator. So that's just what it's going to do. It's running 200 milliamps right now at 9 volts, dropping that across the regulator. All right, so that's good for the time being. I'm going to have to put it in the repeater to test any more, but pretty encouraging so far. All right, so we might as well test the damn thing, right? All right, so I did not put the I did not change out the connector. As you can see, this guy has the little FL1, FL, I don't know, I can't remember the name for that connector. Doesn't have the that little connector on it yet. This one still uses the original antenna, the PC board antenna. I'll be putting that on there later. I'm actually not going to take this board out at this point. The other thing is there is another mistake on this board. If you notice on this guy, it's nicely screwed into a little 3D printed shelf I made. I'm going to do something different with this one because I screwed up and I did not put the mounting screw holes in this board. They're missing. They fell off or something. I don't know. Anyway, so I'm not going to take this board out yet. I want to just prove that it works. So the first thing I'm going to do is, so I put the dummy load on the exciter. First thing I'm going to do is just make sure that everything is working since the last time I powered it up. Probably worth it, right? All right, so it seems to power up and it seems to connect to the net, right? Oh, it won't. It may not connect to the net because of I didn't put the G3 antenna on it. I guess I'll put the antenna on it. All right, there we are. We're connected to the net even, so that works. All right, so in theory, I should be able to turn on my 440 radio and okay. Find the radio. That's just local noise that you're hearing there. Turn on the radio. They can transmit on 6 meters and hope that it actually has a battery that works. So we're going to do an ID first and see if we can hear the ID on the radio. All right. Again, that's the original board. Should be no reason for that to fail. And then N0BEL test, and we have an echo, and we have everything working normally. And there you go. All right. So that's all cool. So we'll power him down, and we will disconnect these guys. Plug them into the new board. I'm not going to bother with the programming port because I'm not going to use the programming port. It's already programmed. Plug in the display, and we'll plug in the main input to the board, which is voltage and all the signals and such and such and so on and so forth. Make sure it's not misaligned. Take another quick look at it, see if there's anything else I missed. Give it some kind of an insulating factor here. And power it up again. And it's talking. And it works. So that command COR light, by the way, I did figure that out. So that was my guess is that the command COR doesn't actually work on the old board. Works on the new board because I had to actually change the program to not do a pull-up on that pin. It should get pulled up from the external device instead. Ignore my noise. That's just local noise on my stupid radio. All right, first we're going to try an ID on this board, and the levels should be completely and utterly incorrect. Very loud. Now that's encouraging, though. At least it works. So now let's see if we can talk through it. And again, the levels will be wrong, so it may not do a PL. It may not key up. We'll see. Yeah, okay. Really freaking loud. Um, it freaking works. And there was a courtesy beep and everything else. All I have to do is set levels, and we're done. And I'll set levels by using the IFR. Hook up the BNCs to these guys. Actually, I'll hook the BNC up to the exciter. Anyway, bottom line is, hey, it works. Well, that was fairly successful. Glad that was and kind of fun. So I started the stuff last night, but really did most of the work over the course of about 6 hours. Is where the from where I left it last night, which is just a stencil sticking on it, to now, because I started about noon today, maybe a little later than that. It's now 5:30, so 5 or 6 hours, not too bad. Kind of cool. Kind of cool. Works. And with that, I'll finish this off. I'm going to stitch these videos together. It'll be totally screwy and unprofessional, but what the hell. There we go. It was still a lot of fun to make this work. And it was more fun kind of having you watch along. We'll see if you liked it as well.